This is the practice section of H8-6 on complex and real roots. Okay, so what I would suggest to you here that you go ahead there and try the problems from this page and then come back and watch the video to check your answers. I'll start out here with number 1. I'm assuming you've already attempted this or you don't know how to do it there, so you're kind of seeing how to do it. So it says a 4th degree polynomial can have at most 4 roots. Figure out all the possible combinations of real and or complex roots. It says, remember, there must always be an even number of complex roots. All right, so if we have a 4th degree polynomial here, okay, so it's like, I'll just put a D for degrees, 4th degree. Okay, the first thing we know, this could have 4 real roots, and we could say, 0 complex roots. Right, so we could have something there. Let's see if I have room to do some sketches of some graphs here. But right, that could go something like this. 1, 2, 3, 4. Kind of like a little W shape, possibly. Now, if we have a 4th degree, right, could I have just one real root? Could I have one real root? If I had one real root, right, that would mean I would have to have 3 complex, but that won't work because we said that it always has to be even. So we'll go ahead there and get rid of that one there, which means, let's see here if we had, actually, let's go backwards since we had said that there were 4 real roots there. Could I have 3 real roots? Could I have 3 real roots plus 1 complex root? That doesn't work either, right, because of the even, so we have to throw that out. So let's go here then with, we have 4th degree. That means maybe if we had 2 real roots, then that means we'd have to have 2 complex roots. Okay, so if we're trying to sketch that, okay, so we know it's got to touch the x-axis twice or have at least a double root, okay, and then it's got to have complex roots. So here's why I draw them here, right? If the degree is 4, that means we're going to have 3 max and mins, because we said that this number here has to be 1 more than the number of max and mins that we've got. So if I start at the top and I come down here, there's a minimum. I'm going to go back up, right? So I have 1 minimum. Now I know I'm going to have to bend back down, so there's 2 minimums, but I don't want it to make it all the way back to the x-axis, so I'm going to curve and go back up this way. So remember, we need to have 3 mins and maxes. So here's 1, here's 2, here's 3. Here are our 2 real roots. That means the other 2 roots we would have to have would be complex there. All right, and then our other possibility here, right? We just said that we couldn't have 1 real root already, so that means we could have a degree of 4 could equal 0 real roots plus 4 complex roots. So I'm trying to draw that one here. Remember, we need to have 3 mins and maxes. We just don't want to make it all the way to the x-axis. So if we started up here, we curved, went back up, curved, went back up, boom. Kind of like our first graph there, but with a vertical shift on it, right? You'll see there's a minimum, there's a maximum, there's a minimum. So that means we've got a degree of 4, and there are no real roots there. All right, let's move on here. Number 2 says identify the minimum degree from each graph below, then the numbers of real and complex roots for each. So just start tracing your graph on A. Let's see, we go down here, we get to the bottom here, that's a minimum. Then it shifts directions again, there's a maximum, then there's a minimum. So our minimum degree, remember, is going to be the number of mins and maxes plus 1. So we've got our, basically like our 3 plus 1 there is going to give us a 4 for our minimum degree. And then it asks how many real and complex we have. Well, let's identify here. We've got 1 real single root here, 1 real single root there. So we have a total of 2 real, which means then we're going to have 2 complex. Letter B. Our minimum degree as we're going through and tracing here, well, it looks like it shifts directions and starts going back down, and then it shifts directions going back up, and then back down, then back up, and then back down. So we have 1, 2, 3, 4, we have 5 mins and maxes, which means our degree is 6, right? Because we take that 5 and we add 1, we get 6 here. So that's our minimum degree. And that makes sense, right? Because both of our end behaviors are down. So if we're going to count the number of real roots that we've got there's 1, there's 2, there's 3, there's 4. So we have 4 real roots. And that means the missing value over here would have to be 2 complex roots. Letter C. As we go through and do this one here, got to be careful. This one's got, I would consider this to be kind of a minimum here, and then it shifts directions again here, right? That's really hard to see right in the middle, but it does. And then it goes down here. So we have 3 mins and maxes, right? And we add that 1, that gives us 4, and that does make sense with the end behaviors being even. So our minimum degree is 4. The number of real roots we've got here, we've got a single root there and a single root there, so that is 2. Which means then our complex roots has to be 2 also. All right, and then the last one here for this problem, we've got, let's see, we're going to count our mins and maxes. So start on the left side and work your way up till it changes directions. Goes back down, back up, back down, back up. So this one looks like we have a degree of 5. And then when we count our real roots, we've got 1, we've got 2, we've got 3. So we've got 3 real roots, and then this one also has then 2 complex roots. 5 equals 3 plus 2. All right, hopefully that has helped you with that one. We'll move on here. Number 3 says draw a graph that has the following numbers of real and complex roots. So it has 2 real roots and 0 complex roots. Okay, so let's just give a little sketch here for our coordinate plane. Oh, that's terrible. Let me undo that. There we go. You know what? Let's just put them all on here real quick while we're doing it. All right, so first one, 2 real and 0 complex. Well, what comes to mind to me would be a parabola. If we have letter B, 0 real and 2 complex, well, think about if we just move that parabola up, right? Now it's got 2 complex and 0 real. Ooh, the last one says 3 real and 2 complex. So that means our degree here is going to be 5, which means the number of min and maxes that we have to have is going to be 4. So just think about, we got to shift directions 4 times. So let's start up here. We're going to go down. There's 1 real root. Here's 2 real roots. There's 3 real roots. Okay, now when you're thinking about where we're at, right, that's 1 minimum. And there's a maximum, so that's a total of 2, right? We need 4. Okay, so then let's look here. This has to end going down because it's an odd degree, right? This is an odd degree. That means we need to bend, but we can't touch the x-axis again, so we're going to have to bend and go back down there. So here is our next minimum and next maximum there. Therefore, we have our 3 real roots, touches the x-axis 3 times, and then we still have another little bend in it there, which would account for our 2 complex roots. If questions, please make sure you contact me. We're moving on. All right, number 4. Just simplify the following expressions without a calculator. All right, I to the third, we said was I squared times an I. Remember, whenever it's an odd number, we can just cut 1 off there. We know this is going to be a -1, and -1 times I would be a negative I. Letter B, we have an even number here, right? So remember, we talked about if we can take that exponent, and if it's divisible by 4, then we know it's +1. So 8 is divisible by 4, so this would be a +1. Remember, if it's not divisible by 4 and it's an even exponent, it'd be -1. I to the 23rd power, right? So this is the same thing as I to the 22nd times an I. We already know the answer is going to be I or negative I because the exponent's odd. So now we're just going to focus on this I to the 22nd. Is this a +1 or a -1? Well, when we take 22, right, and we try to divide it by 4, it does not go in there a whole number of times. It goes in there, like 4.5 times, right? So, I'm sorry, 5.5 times. Geez. So it goes in there 5.5 times. So therefore, this is going to have to be a -1. And we're doing -1 times that I, which is going to give us a -I. All right, another odd one here, right? So we're going to say this is I to the 84th times I. And 84 is divisible by 4. So we're going to say that's 1 times I, which gives us positive I. I to the 126th power. Okay, so that's even. So we need to think about, is 126 divisible by 4? Okay, so here's another way you can think about doing that here, right? If I take anything and I divide it by 4, it's the same as dividing it by 2 twice. So I think it's easier to divide something by 2. If I divide this by 2, I get 63, right? I can't divide 63 by 2. Therefore, this is not going to be a whole number there, right? This would be like 31.5. Therefore, we know that this is -1. Okay, so not divisible by 4. All right, and then the last one, letter F, we have to simplify this here. So if I'm looking at there, I'm going to look at this fraction first. I have I to the 3rd divided by an I to the 4th, and then I'm multiplying it times I to the 16th. Well, I to the 3rd divided by an I to the 4th, if we just reduce that here, right, isn't that the same as 1 over an I? And if I multiply that times an I to the 16th over 1, I now have, I to the 16th over an I, which we can reduce to I to the 15th power. So I to the 15th power, we'll take it now and we'll just do what we've been doing here, right? That's like I to the 14th times an I. I to the 14th, 14 is not divisible by 4, so that's going to be a -1, and then we multiply it times I, we get -I. And that's our answer. You can always check these on the calculator there. Most of the calculators do have an option there where you can put in the I values. All right, simplify the following expressions using the fact that the square root of -1 equals I and I squared equals -1. All right, so this is just a little bit of practice on these. The square root of -64, remember that's the same thing as saying 64 times -1, which is like saying the square root of 64 times the square root of -1, which should be like saying 8 times I, which we can simplify to just 8I. Letter B, 25I squared. That should be a 5I squared becomes 25I squared. I was kind of jumping the gun, right? And then I squared is the same as -1, so this ends up being a -25 to start. Now I'm going to multiply it times a -3I. Negative times negative is a positive. 3 times 25 is 75, and then we only have one I out there, so 75I is the simplified expression. Next one, we're going to be 4 minus 3I, and we're going to square that quantity, so that means we're going to be multiplying it times itself. So when we FOIL it out there, we should have 16 minus 12I minus another 12I plus 9I squared. So this 9I squared is like saying 9 times -1, so that's like a -9. So as we put that together, -9 and 16 is going to give me 7, and then we have minus 24I. D, just like A, except 45 is not a perfect square. So as I take that and break that apart here, right, I know the perfect square factor of 45 is 9. So this is like saying the square root of 9 times 5 times -1. So we have the square root of 9 times the square root of 5 times the square root of -1, which is going to end up being 3 times the square root of 5 times an I, or 3I radical 5. Letter E. Start with the exponent here. We have 7i times the quantity of 2i to the third. Well, 2 to the third is going to be 8. So I have 7i times 8, and then I to the third. Now, I to the third we already did up here in this previous problem, right? Isn't that the equivalent of negative I? So this is saying 7i times 8 times a negative I, which gives us 7i times negative 8i, which is going to give us a negative 56i squared. But we know I squared is the same as negative 1, so this is going to end up being a positive 56. F, we have a negative square root of negative 49. So remember, this negative is going to come into play, but we're looking at the square root of 49 times negative 1, which then means we've got the opposite of the square root of 49 times the square root of negative 1, which should give us a negative 7 times I, which would be negative 7i. Almost done, almost done. 2 more. So 4 times the square root of negative 11. Okay, so we got 4. Now when we take that square root of negative 11, that's 11 times negative 1. We'll break it apart. Now we can't take the square root of 11. That's still going to be what it is, but our square root of negative 1 becomes an I, so we'll end up with 4i times the square root of 11. And last one, letter G, we have 2i plus 5 times the quantity of 6 minus I. So this is going to be one here. We're just going to end up foiling it out. So if I do 2i times 6, I've got 12i. If I do 2i times negative I get a negative 2i squared. If I take 5 and multiply it by 6, that's going to be a positive 30. And then if I do a 5 times negative I get negative 5i. Now our I squared in here is going to become a negative 1. So when we do negative 2 times a negative 1, that's like plus 2. So we have 12i plus 2 plus 30 minus 5i. Now we can combine our like terms. 12 and negative 5i is going to give us a 7i. And then 2 plus 30 is going to give us 32. Our final answer there is 7i plus 32. So hopefully you're staying fresh on these there and you feel good about them. If you have questions, you need to let me know, especially while we're on this break and you're trying to keep up with your studies. This is the end of the lesson part here. Go ahead there and try the homework, and I will go ahead and make some homework videos to try to answer your questions for those problems if you need them. Please reach out to me if you need anything at all. All right, thanks for watching.